Okay, so Unit 6, Lesson 1, perpendicular and angle bisectors. So I'm going to explain what a perpendicular bisector is and some of the properties of it. I'm going to start with the theorem, and then I'm going to explain the theorem in my own words. So, in a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So, in this diagram to the right, AB is a segment. CP, the line CP, is a perpendicular bisector of the segment, meaning it is perpendicular to the segment and it is cutting that segment directly in half. Okay? So, what that does is this point C, or basically any point on that line, okay? Any point on this line CP is the same distance from A as it is from B, okay? So no matter where I drag C along this line, it is the same distance from A as it is from B. And AP and PB are the same because that segment is being cut in half. Now, the converse of this is basically just saying, in a plane, if I have a point D and it is the same distance from the end points of the segment, well then we know D lies on this perpendicular bisector. Okay? So perpendicular bisectors have those properties. They intersect a segment at a 90-degree angle. They split that segment in half, they bisect it, and any point on that bisector is the same distance from the endpoints of the segment it is intersecting. So, in example 1, finding the measure, using these properties to find the measure. So, SQ is a perpendicular bisector of RP, meaning SP and SR or RS are the same length. So that means RS is 6.8. All right? Now EG. HF is a perpendicular bisector of EG because H is the same distance from E as it is from G, meaning this segment EF is 9.5, but I asked for EG, so EG is really 9.5 plus 9.5, which is 19. So EG is 19. In part C, BD is a perpendicular bisector. It's intersecting CA at a 90-degree angle, and it creates two congruent segments. So what we can say is 3x plus 14 is equal to 5x. And I can solve that. Just subtract 3x from both sides. 2x equals 14. X equals 7. But I didn't ask for x, I asked for AD. So AD, I'll do that up here, is 5 times 7, meaning AD is really 35. Okay, so understanding what I'm asking for, reading the diagram, and knowing the properties of perpendicular bisectors is an important thing here. So, this is a good chance for you to get a little bit of practice. Take a second to pause the video, and then I'll show you my answers when I resume the video. Okay, so what I label on the diagram is for number 3, but when we look at this, if ZX is a perpendicular bisector, and YZ is 13.75, YZ and WZ will be the same length, making WZ 13.75. Number 2, WZ and YZ, if it's a perpendicular bisector, are equal to each other, So I set 4n minus 13 equal to n plus 17, solved for n, and then substituted into the expression for yz to get 27 as the length of yz. In the last one, I wanted to illustrate by labeling the known values, the known measurements. So wz and yz were the same, making zx a perpendicular bisector. That bisector is bisecting wy, meaning it's cutting wy into two equal parts. So to find wx, I took the entire length, divided it by 2 to get the measure of wx. Okay, so for the last few examples, we're going to talk about angle bisectors. And an angle bisector is a line, segment, ray, something that cuts an angle in half into two equal parts. So AD, this ray, is bisecting this angle BAC, and DB is perpendicular to AB. These two are perpendicular. DC is perpendicular to AC. If all of that is the case, then that means DB and DC are congruent to each other. So the converse of this, if a point is in the interior of an angle and it's the same distance from the two sides of the angle, then it lies on the angle bisector. So it's just saying that last theorem in reverse. Okay, so mainly remembering with an angle bisector, if a point lies on the angle bisector, it's the same distance from the two sides, all right? So if it bisects it, if it bisects the angle and it creates two perpendiculars, then these two segments are the same length. So in example 3, finding each measure, GFJ. GFJ is this angle right here that I kind of colored in. So the thing is it an angle bisector? Is JF an angle bisector? Well, if we look at it, JG and JH are the same length, and they both create perpendiculars. So yes, it is an angle bisector. So that means this angle, this whole angle, is being cut in half, meaning GFJ and HFJ are the same measure, meaning GFJ is 42 degrees. Okay? RS, in this next example, is it an angle bisector? Yes, it is. Does it create two perpendiculars? Yes, it does. So that means that these two segments are the same length, meaning I can set the two expressions equal to each other. So however you want to solve this is up to you. The way I would solve this, I would subtract 6x from both sides. -5 equals -1x. X is +5. So RS, I would substitute 5 into that expression. RS, 30 minus 5 is 25. So a lot of it is just paying attention to what the measures are. And I know those theorems can be a little confusing, but just try and connect it to the theorem before it or the explanation before it to set up your equations or to decide what's equal to what. Okay, so the last example here I think is the toughest one. It's probably going to take me the longest to explain, but writing an equation of the perpendicular bisector of the segment. So first things first, graph the points. -2, +3, +4, +1. So this is point P, this is point Q, and I'm going to connect them because it's a segment. And I'm going to do my best to connect them, but I probably won't do a good job. That's as straight as I can make it freehand. So a perpendicular bisector of the segment. So we need two things here. We need the slope of the segment, and we need the midpoint. So those are two things that are kind of review, pulling back in our memory banks for this. So slope, we should kind of have y2 minus y1, x2 minus x1. So 1 minus 3 over 4 minus, oops, that's terrible, 4 minus negative 2. So that's negative 2 over 6. The slope of this is negative 1/3. We're gonna store that away for right now. All right. Midpoint. Midpoint. That's going pretty far back. But remember, the midpoint is the average of the x values, the average of the y values. So we're getting an actual point. So to get the average of the x values, negative 2 plus 4 divided by 2. The average of the y values, 3 plus 1 divided by 2. So that's 2 divided by 2, which is 1, and then 4 divided by 2, which is 2. So the midpoint is the point 1, 2. And guess what? If you graph your midpoint and it doesn't look like it's in the middle of the segment, you probably did it wrong. If it doesn't even fall in the segment, you probably did it wrong. So that's one thing. So that gives us a point. That's good. Now the slope. If we want this to be perpendicular slope to negative 1/3 is opposite reciprocal. Remembering that from a few units back. The opposite reciprocal of negative 1/3 is positive 3 over 1. So what I can do is I'll draw my line first. Up 3, right 1. Other way I go down 3, left 1 to create my line. And then it's essentially just writing y equals mx plus b for it. The nice part is we already have the slope. The slope of our new line is 3. The y-intercept happened to fall right there at negative 1. So 3x minus 1 is our equation. So that does take a little bit because it's got multiple steps. It requires you to pull different information in. It requires you to review some things. So keep that in mind, that this is not easy. I'm not saying it's easy, but it takes some time to get down. Okay, so you're probably ready for the practice. Make sure you take your time through that. If you're not doing the paper and pencil practice, it's fine. You're not required to for this unit. You weren't required to for Unit 5. But it helps. It definitely helps with the checkpoints and the quizzes. Because you can use, for virtual, you can use anything you want in the quizzes. I don't care. So just keep that in mind. Keep taking good notes. Ask questions if you need to. Set up Google Meets with me if you need to. I'll help you in any way I can.